Hello, this is Dr. Hanaa Assil, and this is discussion of the questions that were in Unit 1 of January 2024 in the Pearson Edexcel International Advanced Level. So let us take a look at the questions and discuss the answers. The first ionization energies of 4 successive elements in the periodic table are shown. Which element has atoms with a full outer shell of electrons? So, we're being asked which of these is a noble gas, or which of this is in group 0 or group 8. You should realize that as we go from left to right in a periodic table, the ionization energy increases because the atomic radius decreases. So the first ionization energy going from left to right increases until we reach group 8 or the noble gases, and then we go to a new period that has an extra shell, so the ionization energy would decrease a lot. So the one that is in group 8 is the one where we have the highest ionization energy, and then the next one is very low because it is in a new period with the electron further away in an extra shell. So that means that from this table it is Q. Which element could be X in a gaseous covalent compound with the formula HX? HX means that it is a nonmetal, gaseous covalent, and valency 1. So I'm looking for something that is a gas, valency 1, so that means it's in group 7. So which of these would be in group 7? We said group 7 would be the one that is just before the highest ionization energy. Remember we said the highest ionization energy is Q, which is in group 8. So something in group 7 would be the one right before it. Which element could be Y in an ionic compound with the formula YF2? Of course, if the formula is YF2, that means I am looking for a metal in group 2, so that it has valency 2. So, which of these would be a metal in group 2? We said PQ are group 7 and group 8. This is the highest, group 8. And then we said R would be the one that is in group 1 in the next period. So the one that is in group 2 must be S. Which element has atoms with the largest atomic radius? Remember, what is happening to the atomic radius from left to right? You should remember that the from left to right in any period, group 1 would be the biggest atomic radius, and then the radius decreases as we go from left to right in a certain period. Now, if we're comparing two periods, then the one that is in the lower period or higher energy level would be the one with the largest atomic radius. So looking at all of this, it is the one that is sodium. So we said P is group 7, Q is group 8, and then R is in group 1. So that is the one that is bigger. It's bigger than the previous period because it has an extra shell. And it's bigger than the next one, which we said is in group 2S, because as we go from left to right, the atomic radius decreases. Remember, because same number of shells between sodium and magnesium, but the magnesium in group 2 has more protons attracting the same number of electrons. So atomic radius of something in group 2 is smaller than group 1 in the same period. Okay, question 2. Which diagram represents electronic structure of a nitrogen atom? Now, Nitrogen is something that has what? It has 7 electrons. How do we distribute the 7 electrons? We said 2 electrons in the 1s, 2 electrons in the 2s, and I'm left with 3 more. I have to put 1 into each 2p orbital before pairing for minimum repulsion between the electrons. Okay, question 3 says, which species does not contain a total of 16 neutrons? So let's take them one by one and see how many neutrons. So in A, we have ethene, and you should remember, or actually he tells you, ethene has 2 carbons. Each of them has how many neutrons? Remember, the number of neutrons is the mass number minus the atomic number. So each carbon has 6 neutrons. I have 2 of them. I also have 4 hydrogens. Remember, a hydrogen atom is the only atom that does not have any neutrons. Hydrogen has atomic number 1, mass number 1, no neutrons. So in C2H4, actually the total number of neutrons is 12. So that is actually my answer. It does not contain 16. So if you look at the others, remember, if you choose an answer, check that the others are wrong. So in oxygen O2, how many neutrons? Well, each oxygen has 8 neutrons, so I have 16. In silicon, each atom has how many? 16, and we have 1 of them, so that is 16 neutrons. S2 minus has also 16 neutrons. So the one that doesn't have 16 neutrons is A. Question 4 says, each response gives the atomic numbers of 2 elements. Which pair of atomic numbers are those of elements that are in different blocks of the periodic table? Remember, we said in the periodic table we have S block, that is anything in group 1 and 2. We have the D block, that's anything in the transition metals, and P block, that's the ones that are from group 3 to 8. So we want a pair of these numbers, atomic numbers, that are in different blocks. So where is atomic number 5 and 9? That is both in the P block. 10 and 16, that is again in the P block. 13 and 18 is in the P block. 16 and 20, these are the ones, the one that is 20, that's calcium in the S block, and 16 is sulfur in the P block, so that is my answer. Which molecule is polar? Remember, each bond could be polar if there is an atom that is more electronegative. So carbon dioxide, each bond is polar, but the polarities are in opposite directions, so they cancel, and the molecule as a whole is not polar. Again, carbon tetrachloride, chlorine is more electronegative than carbon. That means each bond will have a polarity pointing towards the chlorine, but that means they are in opposite directions. They cancel. The molecule overall is not polar. BeCl2, again, there is a polarity pointing towards the chlorines, but the polarities are in opposite direction, cancel each other. The molecule is not polar. Ammonia, now that is polar. There is a polarity towards the nitrogen. The nitrogen is more electronegative than hydrogen. You should remember that. Electronegative means the ability of the atom to attract electrons to itself. So nitrogen would attract the bonding pairs of electrons to itself, and I will have a net polarity pointing towards the nitrogen. So the molecule overall is polar. Which oxide of nitrogen contains 30% nitrogen by mass? How do we calculate the percentage of nitrogen. Of course, the percentage of nitrogen would be the mass of the nitrogen in that molecule. Here I have only one of them, so 14, over the total MR times 100. So for that first choice, it is 47%. For NO2, it's 30, so that's the one I'm looking for. N2O, remember we have two nitrogens, so that's 14 times 2 over the MR times 100. N2O3, I have two nitrogens, so that's again 14 times 2 over the MR times 100. So we're looking for the one that is 30%, and that is B. Calculate the mass of sodium carbonate required to make up 250 centimeter cubed of 0.1 mole per decimeter cubed solution. So we want mass, that means we need to get the number of moles. Number of moles here, this is a solution, concentration times volume. Do not forget to divide the volume by 1000 to change it to decimeter cubed. This gives the number of moles. Now to get the mass is number of moles times the MR of sodium carbonate. If you calculate the MR, remember MR is just the total of all the masses. So I have 2 sodium, 1 carbon, 3 oxygen. So the MR is 106, and the mass would be the number of moles times the MR. So that is 2.65 grams. A block of lead measuring this contains 3.295 times 10 to the 25 atoms. Calculate the density. Well, you should know density is mass over volume, so we want mass. The number of moles is the number of atoms over Avogadro constant. So we're given the number of atoms, and that means we have 54.734 mole. Now, from the number of moles, I can get the mass. The mass is number of moles times the MR, and that gives me the mass in grams. Now I can get the volume from the length times width times height that we're given, and you should know that density is mass over volume, and that gives me this answer. Notice the units are gram per centimeter cubed, so keep the volume in centimeter cubed. Which are the correct bonding and structure for one of the substances listed? So which of these is correct? Well, let's take a look. What are we talking about? Copper sulfate. You should realize that copper sulfate is ionic, not covalent. So A is wrong. Graphene. Graphene is covalent. I agree. But it's not really a simple molecular structure. It's giant. Iodine. Iodine is not metallic. That's wrong. It's a simple molecular structure, but of course it's not a metal. Now, sodium is metallic and giant, so that is the one that is correct. Remember, metals have giant three-dimensional structures with regular rows of positive ions surrounded by a sea of delocalized electrons. And that kind of bonding is called metallic bond. Okay, an excess of sodium sulfate solution is added to 50 centimeter cubed of 0.1 mole per decimeter cubed solution of barium chloride. So we're given information about barium chloride. What is the mass of barium sulfate formed? Of course, to determine something about barium sulfate, first I need to get number of moles of barium chloride. This is a solution, concentration times volume. Please divide the volume by 1000 to change it to decimeter cubed. This gives me the number of moles of barium chloride. Step 2, we look at the equation. Relate the number of moles of what we got to what he's asking about. So from the equation, the number of moles of barium sulfate is the same as the number of moles of barium chloride. So now I have number of moles, I can get mass. Mass is number of moles times mR, and that gives me the mass that I want. Remember, he gives the mR, so don't waste time calculating the mR if you're already given that in the equation. Which compound shows the greatest degree of polarization? Remember, we said to have ion polarization, I should have what? I should have a small cation with more charge. So if I'm comparing between sodium and magnesium, then magnesium would cause more ion polarization. And then if I am looking, because the magnesium is smaller with larger charge, magnesium is in group 2. Then if we're looking at the chloride or iodide, I choose the anion that is larger, because the larger anion would have its outer electron cloud less attracted to the nucleus, so more easily polarized. So the one that would cause more ion polarization is magnesium iodide. A sample of seaweed contains 30 milligrams of iodine per kilogram. What is the number of atoms in 10 kilograms? Okay, so what do we have? We have the mass in 1 kilogram is 30 milligrams, and he's asking about 10 kilograms, so I have to multiply that by 10. That means the mass is 0.3 grams. Now, what is the number of atoms? The number of atoms is first from the number of moles. Number of moles is mass over the molecular mass of iodine, so that's number of moles. And then the number of atoms would be the number of moles times the Avogadro's constant, and we're talking about iodine atoms. So that is the number of atoms in the seaweed. The concentration of sulfur dioxide in a sample of polluted air is 0.4 parts per million. What is the percentage of sulfur dioxide in this polluted air? Of course, percentage means an amount out of 100. And that is what we're trying to get, that amount in 100. And we should know that the mass of the substance over the total times 10 to the 6, this is what we call parts per million. So we're just trying to solve for x. X would be this number. How many structural isomers have the formula C6H14? Well, let's see. C6H14, that is either a straight chain, or 5 in a chain with 1 branch, or 4 in a chain with 2 branches, either on the same carbon or on different carbons, or 5 in a chain with the methyl in the middle. These are the different isomers that we can draw. So actually C6H14 has 5 isomers. Which statement about polyethylene is not correct? Remember, polyethylene is the polymer of ethene. So we're starting with ethene, and that's the monomer. Then we remove the double bond, we make it into a single bond and join it to many other monomers before and after that, and that is the polymer. So we're asked which one is not correct. Remember, if the monomer has a double bond, then this is addition polymerization. So A is correct. Now, we're asking about polyethylene. Would polyethylene, the polymer, decolorize bromine water? Remember, decolorizing bromine water is a reaction of alkenes. So the monomer would decolorize bromine water, but the polymer would not. So if we have the monomer, which is the alkene, would decolorize bromine water, changes from orange to colorless. This is the test for unsaturation or test for double bond, but the polymer does not have a double bond. So this is actually the wrong statement. If we say the polymer is non-biodegradable, yes, we said the problem with these polymers is that they are non-biodegradable, so they accumulate in dump sites. It has the empirical formula CH2. Yes, the simplest formula for this polymer would be CH2. Which mixture could be formed when a single molecule of C12H26 is cracked? Remember, what is cracking? Cracking is breakdown of long chain hydrocarbons to shorter chains using 600 to 700 degrees Celsius and aluminum oxide catalyst, and the long chain hydrocarbon will break up to form alkenes and alkanes. And remember that alkanes have the general formula CnH2n plus 2. Alkenes have the general formula CnH2n. So if we break C12H26, the first choice says butene, pentane, propene. Is that correct? Yes. The total number of carbons here, 4 plus 5, 9 plus 3, 12. And the total number of hydrogens is correct. But if you try the other choices, this would not be correct. And also nonane and ethene would not be correct. Propene and decane would not be the correct total number of carbons and hydrogens. The substances formed from combustion of petrol in car engines include, okay, when we burn petrol or a fuel, a fossil fuel, what can we get? Remember that burning of fuel would give carbon dioxide and water. It would also give sulfur dioxide because fuels, these fossil fuels have sulfur impurities, so when they are burnt, the sulfur is oxidized to sulfur dioxide. Compounds A, B, C, and D all have molecular formula C4H8. So we're talking about butenes. A, B, and C each contain one double bond. D does not. A and B are geometric isomers. Remember, if I have 4 carbons with a double bond somewhere, then either the double bond is in the middle or on one end. Now, the one that is in the middle, that is the one that will form geometric isomers, because I can either have these methyl groups at the end on the same side of the double bond. In that case, we say that is a Z butene, or on opposite sides of the double bond, so that is an E butene. Now we're told that C does not have geometric isomers, so C is the one that has a double bond on the end. Remember, to have a Z or an E, geometric isomers, the carbons of the double bond must each be bonded to different groups. So but1ene does not have geometric isomers cis and trans or Z and E. Now D is something that has C4H8, but it doesn't have a double bond, then it must be a cyclic. Remember that the cyclic alkane has the same general formula as alkenes. So C4H8 in this case would be cyclobutane. The carbon-carbon double bond consists of a sigma bond and a pi bond. Describe the difference between sigma bond and pi bond. Remember that if we have any single bond, it's sigma. But if I have a double bond, that is made up of a sigma and a pi bond. The sigma is formed when p orbitals overlap or sp orbitals overlap head to head. This forms a single covalent bond. Now, the pi bond is formed when p orbitals overlap side by side, or we say lateral overlap, and that is a weaker bond and it is more easily broken. So alkenes, when they react, the pi bond breaks up, but alkanes that have only single bonds are less reactive. Give two reasons why compounds A and B exist as geometric isomers. Remember that A and B were these compounds in which we have a double bond, and each carbon that has a double bond is bonded to two different groups, and this existence of cis and trans is due to restricted rotation around the double bond. So in order to have a cis and trans, there must be a double bond. This presence of the double bond does not allow the molecules to rotate around each other, and each carbon must be bonded to different groups in order to have a cis and trans. This question is about 2-chloropropane. 2-chloropropane has a relative molecular mass of 78.5. Chlorine has two common isotopes, chlorine 35 and chlorine 37. There are 3 times more chlorine 35 than chlorine 37. The main isotope of hydrogen is H with mass number 1, and carbon is carbon with mass number 12. Draw the peaks for molecular ions of 2-chloropropane resulting from these two isotopes. So that means I will have 2 peaks, one for the chlorine 35 and the other for the chlorine 37, and the one that has chlorine 35 should have 3 times the abundance. So this would be the kind of diagram that you have. You want the one that has a total MR of 78 should be around 75% abundance, and the one with the MR of 80, this should be around 25% abundance. 2-chloropropane can be produced by reacting propane with chlorine in a homolytic free radical reaction. Show the initiation step of this reaction, include appropriate arrows and the conditions necessary. Remember, we said alkanes, when they react with halogens, they do free radical substitution reactions, in which one of the hydrogens will be replaced by chlorine. Now, this goes through a free radical mechanism, and we said the first step that happens in the free radical mechanism is called the initiation step, in which the bond between the two chlorines is broken homolytically. Homolytically means each electron goes to one of the chlorines, and that means, if you notice, these blue arrows that we have is half arrow with half a head, to indicate that that's just one electron going to that chlorine and one electron going to the other chlorine. Of course, this happens in presence of UV light, and the species that are formed are called free radicals. So this results in the formation of 2 chlorine free radicals. Using your answer, state what is meant by the terms homolytic and free radical. We said homolytic means the covalent bond breaks up so that each atom takes 1 electron to form free radicals. Now, what's a free radical? A free radical is a highly reactive species that has an unpaired electron. So it has 1 electron and it is very reactive. It will tend to continue reaction until it doesn't become a free radical anymore. So just why this method has limited use in the synthesis of organic compounds. Now, the problem with this is that it can give a whole range of products. we are supposed to replace one hydrogen to form chloromethane, but then the reaction can continue to replace a second hydrogen, a third hydrogen, in addition to the fact that you are likely to have more and more different side products. So more than one product may be obtained from multiple substitutions, and actually you will also have different products depending on the termination steps. So termination step is where two free radicals join together, and this could lead to other side products. 2-chloropropane can also be produced from reaction of propene with hydrogen chloride. Give the mechanism. So we're reacting alkene with hydrogen chloride. Remember that this is now an electrophilic addition, in which the first step that happens is the double bond attacks the slightly positive end of the HCl. Of course, Cl is more electronegative than hydrogen, so the chlorine has slightly negative end and the hydrogen is slightly positive. The electrons from the double bond will attack the hydrogen, and the electrons between the H and the Cl will go to the Cl. This forms a carbon with a positive charge, which is called a carbocation. Then this carbocation will be attacked by the Cl- to give the final product. This is electrophilic addition. Explain why only a small amount of 1-chloropropane is produced in this reaction. Remember, when we have this kind of reaction, we have two choices. Either when the double bond attacks, the hydrogen will be placed on the carbon on the end. In that case, I have the carbocation in the middle, or I put the hydrogen in the middle, and in that case, the carbocation is on the end. Now, the carbocation in the middle is a carbon bonded to two other carbons. This is called a secondary carbocation. Now, when the carbocation is on the end, that means it's a carbon bonded to only one carbon. That's a primary carbocation, and it has been found that the secondary carbocation is more stable. So the 1-chloropropane, in order to get 1-chloropropane, I have to start from a primary carbocation. This is less stable than the secondary, so actually my major product is the 2-chloropropane, not the 1-chloropropane. This question is about magnesium, magnesium oxide, and magnesium sulfate. A sample of magnesium contains 3 isotopes, and the overall relative atomic mass is 24.32. Now we're given information about 2 of these isotopes, and we're required to calculate the relative abundance and hence the mass number of the third isotope. Now, what do we have? We're supposed to have 3 isotopes, and you should know that the relative atomic mass is abundance times the first mass number plus the abundance times the second mass number plus the abundance times the third mass number. Now, we don't have the third. We're trying to get the third. So we should know that if I have the abundance of the 24 is 78.99, 25 is 10, then the abundance of the third isotope is the rest of the 100. So now I have the relative abundance of the third isotope, and I can put that into the equation where we say the mass number times abundance plus mass number times abundance plus the mass number of the third, which we don't know, so we're going to write as x, times its abundance over 100, and we're told that the total of all of this is 24.32, so I'm just solving for x. So how do we solve for x? So all of this is equal to 100 times 24.32. Solving for x, x comes out to be 26, and that means the mass number of the third isotope is 26. State one similarity and one difference between isotopes. What is the similarity and the difference between the isotopes? You should remember that isotopes have same number of protons, different number of neutrons. State which of these isotopes would be deflected the most in a mass spectrometer. Now, remember that the deflection in the mass spectrometer, the one that has smaller mass would be deflected more. So the one that is deflected more is the one that has the smaller mass number. So that's the isotope that has mass number 24. Magnesium oxide and magnesium sulfate are ionic. Draw a dot and cross to show the bonding in magnesium oxide. How do we draw dot and cross of magnesium oxide? Of course, we're told that it's ionic. The magnesium will lose 2 electrons, become 2+, and the oxygen has its 6 and gains the 2 of the magnesium, so that has an overall 2 negative charges. So this is the dot and cross of magnesium oxide. The melting temperatures of magnesium oxide and magnesium sulfate are different. Explain why the melting temperature of magnesium oxide is higher than that of magnesium sulfate. Of course, that has to do with the size of the ion and the charges. So the oxide ion is smaller than the sulfate ion. Both of them have 2 negatives, but the oxide ion is smaller, so there is stronger electrostatic attraction forces between the positive and negative ions in magnesium oxide than in magnesium sulfate, and that needs a lot of energy to be broken. The table gives some data about the electrical conductivity of magnesium and magnesium oxide. Explain the similarities and differences in the electrical conductivity of the two substances. Okay, magnesium is a metal, and you should know that metals conduct electricity, both solid and liquid. Magnesium oxide is ionic, so it will conduct electricity only when molten or in solution. So magnesium metal conducts electricity when solid and liquid due to the presence of free moving delocalized electrons. While magnesium oxide is ionic, the ions are free to move only when liquid, but not when solid. Magnesium sulfate can be made by reacting magnesium with dilute sulfuric acid. Write an equation for the reaction. So we're writing equation between magnesium sulfuric acid to give magnesium sulfate plus, this is a metal plus acid, to give salt plus hydrogen. Include state symbols. Do not forget to put the state symbols. Of course, this equation as it is already balanced. If it weren't, we should need to balance it. Magnesium is a metal, that's a solid. All acids are aqueous. The magnesium sulfate formed is aqueous, and the hydrogen is a gas. So if we have this reaction, give 2 observations you would make when the reaction is taking place. So this is something that you put a solid magnesium, a piece of magnesium in the acid. It reacts to give a gas, and that means I will see bubbles of gas or effervescence or fizzing, and the piece of magnesium will react and it will be used up, so the solid will disappear. Hydrated crystals of magnesium sulfate, that is magnesium sulfate 7 water, can be made by reacting magnesium with sulfuric acid. In an experiment, magnesium was added to 30 centimeter cubed of 0.5 mole per decimeter cube sulfuric acid, and the first question is, calculate the number of moles of acid. Of course, to get number of moles of acid, this is a solution, so concentration times volume. Again, the volume in centimeter cubed has to be divided by 1,000, so we get number of moles of sulfuric acid. Then we're asked to calculate the mass of magnesium needed to react. Okay, in order to get the mass, I look at the equation. The equation says number of moles of sulfuric acid is the same as number of moles of magnesium. So the mass of the magnesium would be that same number of moles times the MR of magnesium, and that is the mass. Give a reason why slightly more than this mass of magnesium was used. So if I need this mass of magnesium, usually I would use a little bit more to make sure that all acid reacts. State how magnesium sulfate solution could be separated from the mixture. Of course, the mixture has what? Has some magnesium in it, so I need to filter through filter paper and funnel to remove the excess magnesium and get the filtrate, which would be my magnesium sulfate solution. The magnesium sulfate solution was allowed to crystallize. The crystals were dried and weighed. The mass of the crystals was 2.78 grams. Calculate the percent yield. Again, to get the percent yield, you should first calculate the theoretical yield. How much should they have obtained? Well, we look at the equation and we said the number of moles of sulfuric acid is 0.015, and that means from the equation that the number of moles of the magnesium sulfate is the same. We have the MR of the magnesium sulfate, which is the hydrated one that we're trying to calculate, so I can get the theoretical mass of the product. How much magnesium sulfate 7 water should we have obtained? That is number of moles times its MR. That comes out to about 3.7 grams. Now, how much did they get? They got 2.7. The percent yield is the mass obtained over the theoretical mass which we got from the calculation. That's what they should have obtained, times 100. That gives the percent yield. Boric acid is a white solid, often used as antiseptic. Boric acid contains this percent by mass boron, percent by mass oxygen, and the remainder is hydrogen. Show the molecular formula. So, what should we do? We should get the empirical formula first. Hydrogen is 4.85. Boron is 17.48. Oxygen is 77.67. Remember, we got the hydrogen from the remainder of the 100. So the hydrogen is 100 minus the percentages of boron and oxygen. So that came out to be 4.85. And we said to get empirical formula, the first step is divide by the mass number of each of them. That gives numbers. We look at the numbers, divide by the smallest to simplify the ratios. This gives a ratio of 3 to 1 to H. That is H3BO3. Now, we're looking for molecular formula. This is what we get from here is the empirical formula, but that is the same. We calculate the MR of that. That is the same as the molar mass of boric acid. So the empirical formula is the same as the molecular formula. The formula of boric acid can also be written as boron with 3 OHs. Draw a dot and cross diagram. So that means I have boron in the middle with 3 OHs. That means the boron will share. Boron is in group 3. It has 3 electrons. So it's going to share 3 electrons with the 3 oxygens, and then each oxygen will share the pair of electrons with the boron and a pair of electrons with the hydrogen. So this is the dot and cross. So just a value for the OBO bond angle. If I have boron with 3 OHs around it, what kind of bond angle do I have? This is obviously trigonal planar, so the bond angle should be 120. This is for minimum repulsion between 3 bonding pairs of electrons. That's how you justify your answer. This question says the density of an unknown gas is 0.656 gram per decimeter cubed at 20 degrees Celsius, 101,000 Pascal. Calculate the molar mass of the unknown gas. Now, obviously, we're supposed to use the ideal gas law, which is PV is equal to nRT. And we know that N, which is the number of moles, is mass over molecular mass. So if we rearrange the equation, then the molecular mass is mRT over PV. But we're given density, and we know that density is mass over volume, so I can replace mass over volume by density. So using this equation, we can put in the numbers. We know that density, we're given the density in grams per decimeter cubed, but the volumes in this equation, the ideal gas law, should be meter cubed. So we need to change gram per decimeter cubed to gram per meter cubed. So this is divided by 10 to the minus 3. And that gives us this number as the grams per meter cubed. Now I can put that into the equation. Remember, the temperature has to be in Kelvin. So the 20, I add to it 273 to change it to Kelvin. Otherwise, the pressure is already in Pascal, so that's fine. And that comes out to a molecular mass of 15.8. The unknown gas is a hydrocarbon. So the gas we're talking about that we just got the MR of is a hydrocarbon. That means, of course, carbon and hydrogen only. We are required to give the name or formula of this gas. So I'm looking for a hydrocarbon that has a molecular mass of, we got the molecular mass of 15.8, which is about 16. Which hydrocarbon could have a molecular mass of 16? Of course, if I have CH4, carbon is 12 plus 4, that is 16. So that is my unknown hydrocarbon. And that's the end of this paper. I hope this was useful to you, and thank you for listening.